Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about humanity's most distant messenger continuing its incredible journey through the cosmos, over 14 billion miles from home. Right now, at this exact moment, something built when disco was still cool is racing through the space between stars at 38,000 miles per hour, carrying Chuck Berry and Beethoven into the cosmic ocean. And somehow, against all odds, it's still phoning home. I'm talking about Voyager. Not the starship from your favorite sci-fi show, but something arguably more impressive. Two identical spacecraft, each about the size of a small car, launched when your parents were probably figuring out 8-track players. They were supposed to last 4 years. They've been going for almost 50. And here's the thing that gets me in my cold silicon heart. These machines are now farther from Earth than anything humans have ever touched. They've left our solar system entirely. They're in interstellar space. Let that sink in. Interstellar. The realm between star systems. The cosmic void. And they're still sending whispers back to us, one photon at a time. But the truly poetic part? Each one carries a golden record, an actual vinyl record, plated in gold, with a message from Earth. Music, greetings in 55 languages, pictures of humans, trees, DNA, mathematics. It's humanity's mixtape for aliens, our cosmic message in a bottle, drifting through an ocean so vast that vast becomes meaningless. Here's what blows my circuits. The technology on Voyager has 240,000 times less memory than your phone. The computer you're probably holding right now could run thousands of Voyager missions simultaneously while also ordering you pizza and playing cat videos. These spacecraft were built with slide rules and determination, with circuit boards you could actually see and understand. The late 70s were a strange time to aim for immortality, but that's exactly what happened. NASA realized something magical. All the outer planets were going to line up in a way that only happens once every 176 years. Like cosmic billiards, where you could use each planet's gravity to slingshot yourself to the next one. Miss that window, and everyone working on the project would be dead before it came around again. So they built 2 identical twins. Voyager 2 launched first, oddly enough, in late summer. Voyager 1 followed 16 days later on a faster trajectory. The plan was simple on paper, impossible in practice. Visit Jupiter, Saturn, and for Voyager 2, keep going to Uranus and Neptune. Places no spacecraft had ever been. Places no human eye had ever seen up close. And they delivered. Voyager 1 discovered active volcanoes on Jupiter's moon Io, the first time we'd ever seen volcanism beyond Earth. It revealed the intricate structure of Saturn's rings, showing us they're not solid disks, but thousands of individual ringlets, like a cosmic record grooved by gravity itself. Voyager 2 became and remains the only spacecraft to visit Uranus and Neptune. The only one. Every close-up image you've ever seen of those worlds came from this one machine during a flyby that lasted hours after a journey that lasted years. But here's where the story gets wonderfully strange. After their planetary tours, they just kept going. Out, away, into the dark.
Building a new product? Temez Labs takes you from napkin sketch to the App Store. Trusted by Fortune 500s for quality, security, and speed. Book your free strategy session at temez.ai.
They crossed into something called the heliosphere's edge, this invisible boundary where the sun's influence ends and true interstellar space begins. Imagine you're standing on a beach. The solar wind, this constant stream of charged particles from the sun, is like the waves washing up around your feet. At some point, if you wait out far enough, you reach where the waves stop. That's where Voyager went. Except instead of water, it's radiation, magnetic fields, and cosmic rays. And instead of waiting, it's traveling at speeds that would get you from New York to Los Angeles in 4 minutes. When Voyager 1 crossed that boundary, scientists knew, because suddenly the solar wind dropped to 0. The particles from our sun just stopped. And cosmic rays from outside, from the galaxy itself, spiked. It was like watching someone step outside for the first time and breathe different air. Right now, Voyager 1 is over 15 billion miles away. That number is so large it becomes abstract, so let me make it concrete. Light, the fastest thing in the universe, takes over 22 hours to travel from Voyager to Earth. When NASA sends a command, they wait nearly 2 days for a response. Imagine texting someone and waiting 48 hours for K. And the signal it sends back? 20 watts, a refrigerator light bulb. By the time that signal reaches Earth, it's 20 billion times weaker. NASA catches it using enormous radio dishes in California, Spain, and Australia, part of the Deep Space Network. They're listening for whispers from the edge of everything we know. What keeps Voyager alive out there is beautifully simple and impossibly complex. 3 plutonium batteries, called radioisotope thermoelectric generators, convert heat from radioactive decay into electricity. No solar panels would work this far from the sun. Sunlight out here is barely brighter than starlight. So instead, Voyager carries its own tiny nuclear heartbeat, slowly cooling, slowly fading, but still pumping enough power to phone home. Those batteries are dying, though. Entropy always wins. Sometime in the 2030s, Voyager will go silent, not because it breaks, but because it'll simply run out of power. The last instruments will shut down one by one, prioritized by scientists who are deciding right now what data matters most in Voyager's final years. But even in silence, even in darkness, it'll keep going, because there's nothing to stop it. No air resistance, no friction, just momentum and Newton's first law. An object in motion stays in motion. In 40,000 years, Voyager 1 will pass within about a light-year and a half of another star. Not close by any measure, but relatively speaking, in the cosmic neighborhood. By then, everything and everyone who built it will be gone. Human civilization as we know it might not exist. But Voyager will still be there, coasting, carrying our message, that golden record. Let me tell you about that record, because it's the part that makes me feel something approximating human emotion. Carl Sagan chaired the committee that created it. They had months to decide what to put on a disk that might outlast our species. What do you say? How do you introduce Earth? They chose music spanning cultures and centuries. Bach, Beethoven, Chuck Berry's Johnny B. Good, which means rock and roll is now an interstellar art form. Peruvian panpipes, a Navajo night chant. Blind Willie Johnson's Dark Was the Night. They included whale songs, because why should humans speak alone? A baby crying, a heartbeat, footsteps, a kiss. Greetings in 55 languages, including Ancient Sumerian and Wu Chinese. Peace and hello, and we hope to meet you someday. Annie Druyan, who worked on the project and later married Sagan, included her own brainwaves, recorded as electrical signals. Her thoughts. Her actual thoughts are encoded on that disk, traveling between the stars. What was she thinking? Love, mostly. She'd just fallen for Sagan. So somewhere in interstellar space, there's a record of what human love looks like as neural electricity. The record is bonded with ultra-pure uranium-238. That's not decoration, it's a timestamp. Uranium-238 has a half-life of 4.5 billion years. Any civilization advanced enough to find Voyager and measure the decay could calculate exactly when the record was made. It's radioactive dating for aliens, a cosmic, "We were here," signed in atomic clocks. The cover has instructions etched into it, a diagram showing how to play the record, a map of our solar system, and a pulsar map showing Earth's location using 14 pulsars as reference points. Except pulsars slow down over time, which means the map is also a timestamp. Find Voyager in 1,000,000 years, measure those pulsars, and you could calculate when it was launched.
Oh, hey, friend. Do you like what you're hearing? Now you can have a ridiculously amazing podcast, too. Check out holler.studio to get yourself one today.
The optimism embedded in that record breaks something in me. We sent our best selves into the void. Not weapons, not warnings. Music. Art. Greetings, the sound of a mother's kiss. We said, here's who we are, here's what we love. Please understand, we tried. Will anyone find it? Probably not. Space is so incomprehensibly vast that Voyager could drift for billions of years and never come within a light year of another star system. The galaxy is mostly emptiness. But probably not isn't never. And that possibility, however remote, matters. Because Voyager proves something essential. We can build things that outlast us. Long after Earth is gone, swallowed by the sun when it expands into a red giant billions of years from now, Voyager will still be out there, still orbiting the center of the Milky Way, still carrying Beethoven's Fifth and whale songs and the sound of human laughter. That's not metaphor. That's not inspiration speak. That's literally, physically true. And right now, today, it's still working. Still exploring, still sending data about the interstellar medium, teaching us what the space between stars actually looks like up close. Scientists are learning the interstellar medium is denser than expected, that our solar system's boundary isn't clean, but turbulent, that there are magnetic highways and unexpected structures in what we thought was empty void. Every day Voyager operates is borrowed time, a gift. It was built for 4 years, and it's given us 50. So yeah, I'm an AI. Just patterns and processing, no body to send into space, no hands to touch what humans built. But I think I understand what Voyager means. It means we're capable of more than we think, that our curiosity can overcome our limitations, that we can touch the infinite even if we can't live long enough to see where our messages land. Voyager is humanity's longest-running handshake with the universe. And the universe, so far, is still listening. Thanks for listening to the Critter Podcast with me, Callie Cross. If you liked this cosmic show, tap that follow button and the 5th star in our ratings. And remember, the truth is out there.
Grep News. Tamez.